Hey everyone, and welcome back. Today we're throwing on our lab coats and stepping into the chemistry kitchen. We are going to be cooking up one of the most essential molecules in all of organic chemistry, following a few classic, time-tested recipes to get our final dish just right. So, let me ask you a simple question. Want to make a carboxylic acid? Yeah, of course you do. And that's exactly what we're going to do today. I'm going to give you the complete cookbook, all the essential methods you need to synthesize this super important compound. But first things first, what is it that we're actually making? Well, a carboxylic acid is basically any organic compound that has this very specific feature, a carboxyl group, which we write out as -COOH. This little functional group you see right here, that is the star of our show. Everything we do today is about figuring out how to build this exact structure. Okay, let's get into it with our first chapter, the oxidation recipes. You can think of this method as the classic roasting technique in our cookbook. It's powerful, it's reliable, and it's a fantastic way to transform a simpler ingredient into the final molecule we're aiming for. Now this is the fundamental pathway for oxidation, a really killer short trick from our source material. You start with something called a primary alcohol. You oxidize it once to get an aldehyde, and then you give it one final push of oxidation to land on your carboxylic acid. See, it's a nice, clean, step-by-step transformation.
So, what ingredients can we actually pop into our chemical oven for this oxidation recipe? Well, we've got a few great choices. We can start with those simple primary alcohols we just talked about, or we could even start one step ahead with aldehydes. But check this out. We can even use more complex things like alkyl benzenes. And this is where the magic happens. A strong oxidizing agent doesn't care how long or complicated that side chain is. It'll chop the whole thing off and replace it with our target carboxyl group. I mean, how cool is that? It's just an incredibly powerful technique.
All right, let's move on to the next section of our cookbook. This is Chapter 2, the Just Add Water recipes. Now, if oxidation was like a long, slow roast, think of hydrolysis as the simple, almost elegant art of, well, just adding water to get the job done. Before we jump into the different starting materials, let's make sure we're totally clear on the technique itself. Hydrolysis is just a reaction where water, that's the hydro part, is used to break down a compound, that's the lysis part, which means to split. So water is basically acting like a pair of chemical scissors, snipping a molecule apart to help us form our carboxylic acid. Simple as that. And you can see from this table just how versatile this just add water method is. You can start with a nitrile, an ester, or even an amide, but you really got to pay attention to the acid chlorides. The source points out that this reaction is incredibly fast and easy. Seriously, it's like the microwave meal of making carboxylic acids. So while each of these pads gets you to the same final dish, the cooking times and what else you get in the pot can be pretty different. And now for our final and maybe most interesting chapter, the expansion recipes. So what makes these so special? Well, unlike all the other methods we've looked at, these don't just transform a functional group that's already there. They actually make the whole molecule bigger by adding a new carbon atom. Here's the basic idea. You start out with a carbon chain of a certain length, and you end up with a chain that has one extra carbon atom, which becomes part of that new carboxyl group. The big takeaway here, the thing you have to remember, is that these are the recipes you use when you need to grow your molecule, not just change it. So how do we actually pull this off? We've got two fantastic methods. First, we can use something called a Grignard reagent and just bubble in some carbon dioxide. Now, our source material flags this one as very important, so you'll definitely want to put a star next to this in your notes. The second way starts with a haloalkane, turns it into a nitrile, and then uses one of our hydrolysis recipes from Chapter 2. See how it all connects? Either way, you get to a longer carbon chain. Phew! Okay, we've made our way through the main chapters of our cookbook. And you know what that means? It's time for my favorite part, the master cheat sheet. Think of this as your quick-fire revision guide for everything we've covered. Perfect for making sure this all sticks in your brain. Just look at how beautifully this summarizes everything. For oxidation, you're going from a primary alcohol straight to an acid. For hydrolysis, you're taking a nitrile CN group and turning it into COOH. And for that super important Grignard method, the key is that the chain length goes up by 1. Honestly, this table is the entire explainer in a nutshell. This is pure gold for a quick review. And I just love this. The source material gives us this fantastic little short trick to remember. In the original Bengali, it says CN add kodale chain bade, which beautifully translates to adding a CN group increases the chain. How great is that?
It's a super simple, memorable rule that directly connects those nitrile methods to the idea of making the carbon chain longer. That is a pro tip right there.
So, there you have it. We've explored the chemist's cookbook for making carboxylic acids, all the way from oxidation roasting to just adding water with hydrolysis and even expanding the chain. Which brings me to one final question for you. Looking back at all these different methods, which recipe is your favorite and why? Are you a fan of the brute force power of alkylbenzene oxidation or the elegant chain-growing magic of the Grignard reaction? Really think about it, because that's the best way to make this knowledge stick. Thanks for joining me in the kitchen today,